Okay, we're looking at the second part of our bounds video. These questions get a little bit more complicated than the previous ones, just because you have to do calculations now. So upper and lower bounds in calculations. So let's say we have 10 identical elephants in a line. Ridiculous question. They are 405 centimetres long to the nearest 5 centimetres. Again, a ridiculous idea. What is the upper bound and lower bound of the length of 10 elephants? So you can imagine 10 elephants lined up in a line, okay? They're all identical, they have been measured, and some guy, for some reason, decided to round their measurements to the nearest 5 centimetres, and he said they're 405 centimetres about. Absolutely ridiculous. So, what is let's look at one elephant to start with. So the upper bound for one elephant, again on a number line, 405 centimetres. We're rounding to the nearest 5, so let's go up in 5s. So 410 that side, 400 that side. So the midpoint between 405 and 410 would be the boundary point between them. Anything bigger or that point I would have rounded up, but this is the boundary. This boundary would be 407.5 centimetres. So the upper bound is 407.5 centimetres. The lower bound, well, it's 402.5 centimetres. And you could imagine a dotted line between 400 and 405 centimetres. Okay, I hope you're happy with that. That's just the previous video. So now 10 elephants. Well, 10 elephants, they're all identical, so we're going to times them by 10. So the upper bound for 10 elephants would be 4,075 centimetres. The lower bound would have been 4,025 centimetres. Okay, or 40 metres and 75 centimetres compared with 40 metres and 25 centimetres. I suppose it's not really that important, but maybe if you were trying to put all the elephants through a sideways door and there was a gap of ½ metre, then they would fit in one case, but they wouldn't in the other. As I said, ridiculous question. Next, this is a more common question. This calculation involves division, and division is the sticking point for upper and lower bounds, and we'll get there. So let's say we had this rectangle, and it's 20 centimetres squared. Let's say we had this side length, and it's 6.7 centimetres. Okay, that's all we know about this question so far. This question you are going to need your calculator to do it, so make sure you have one of those. Finley, put your phone away and get your proper calculator out. So the area of the square, why did I say square? I clearly meant rectangle. The area of the rectangle was measured to the nearest 10 centimetres squared. Okay. The side length was measured to the nearest millimetre. Okay. So the area of the rectangle was measured to the nearest 10 centimetres squared. The side length was measured to the nearest millimetre. So what is the value, the upper bound and lower bound of x? Okay, x being the other side, the shorter side in this case. Right, let's look at the area first. Like we looked at one elephant in the previous question, we're going to look at the area and the length separately. So the upper bound of the area, well, you could draw a number line again and you get 25 centimetres squared. The lower bound, that would be, because it's to the nearest 10, 15 centimetres squared. Okay? If you're not sure about that, draw a number line as we did in the previous ones, going up in tens. The side length, well, it's to the nearest millimetre. Okay, so if we were to do a number line, which hopefully we'll do in a second, then the upper bound you would find would be 6.75 centimetres, and the lower bound would be 6.65 centimetres. Yeah, so here, if we're going up in millimetres, 6.7 centimetres would be here, going up by 1 millimetre would be 6.8, and down by a millimetre would be 6.6. So the upper bound would be halfway between 6.7 and 6.8, which would be 6.75, and the lower bound would be at 6.65. Right, so x. How would we find x? How would we calculate it? We would do the area divided by the side length. This would give us x. So we need to now find the upper and lower bound of x. So let's look at the upper bound first. So the upper bound of x. So what are we going to do to find the upper bound? If we did 25 centimetres divided by 6.75 centimetres, if we did the upper bound divided by the upper bound, that wouldn't give us the maximum possible value of x. To give us the maximum possible value of x, we're going to do the upper bound of the area divided by the lower bound of the side length. The upper bound divided by the lower bound. Because if we do a bigger number divided by a smaller number, this will give us a bigger answer. Think about it. 10 divided by 2 is bigger than 10 divided by 3. So if we do the upper bound divided by the lower bound, that will maximize x and give us the upper bound for x. Okay? In this case, the upper bound, if we do this on our calculator, will be 3.76 centimeters to 3 significant figures. Lovely. Hopefully that gives you an intuition for how to do the lower bound. So if you could do the lower bound of x for me on your own, that would be very good of you. The lower bound of x. So in this case, if we do a smaller number divided by a bigger number, we're going to get the lower bound. So the lower bound of the area divided by the upper bound of the side length. The smaller number divided by the bigger number. The lower bound divided by the upper bound. When you do this in your calculator, you get 2.2 centimeters to the nearest 3 significant figures. So, to answer the question, the side length, what is the upper bound and lower bound of x? The upper bound of x is 3.76 centimeters, and the lower bound of x is 2.22 centimeters. You have to be careful with division, and you have to think very carefully about how you are going to get the maximum value at the end of the calculation. To get the maximum value, we're going to do a big number divided by a smaller number, and to find the lower bounds, to find the minimum, we're going to do a smaller number divided by a bigger number. Okay? We'll do some practice of this in lessons next week. I hope you followed up to now. Keep your questions with you. Bring them on Monday. I look forward to seeing you then.